Question 1. To the lens of integrating smart control systems into an existing HVAC installation, which of the following best explains the primary benefit of utilizing zone control in a residential green building? A. Eliminates the need for thermostats altogether. B. It ensures a uniform temperature throughout the building at all times. C. It allows for targeted heating and cooling, increasing energy efficiency. D. It reduces the SEER rating requirement for HVAC equipment. Answer. Correct answer. C. Explanation. Zone control systems segment a building into areas with independently controlled climates. This allows occupants to condition only occupied zones, reducing unnecessary energy use. By targeting thermal comfort where it's needed, zone control aligns with ASHRAE Standard 90.1 and Energy Star guidelines for efficiency. It doesn't eliminate thermostats. It doesn't require uniform temperatures. B. And does reduce equipment SEER requirements. D. Instead, it directly reduces system runtime and energy waste. Key goals in green HVAC design. Question 2. In contrast to traditional HVAC systems, today refrigerants like R1234F are increasingly being promoted. What is the most critical factor limiting their widespread adoption? A. Lack of compressor compatibility in newer systems. B. Higher flammability ratings compared to HFCS. C. Poor thermodynamic performance in commercial systems. D. The absence of international approval by the Montreal Protocol. Answer. Correct answer. B. Explanation. It-dope refrigerants like R1234F and HFO have very low global warming potential, making them a sustainable alternative to HFCS. However, a major barrier is their mild flammability, classified as AL under ASHRAE 34, which raises safety and regulatory concerns in some jurisdictions, while newer compressors are compatible and their thermodynamic properties are sufficient. C. Montreal Protocol actually supports their adoption under the Kigali Amendment. D. Safety standards such as all 603.352.40 must be followed when using our refrigerants. Question 3. As illustrated by the following situation, Tisdale is designing a geothermal system for a new sustainable school campus. The location has access to a consistent ground temperature of 58 degrees and sufficient land for horizontal loops. However, budget constraints and potential trenching costs are a concern. What system choice best supports long-term energy efficiency without excessive installation expense? A. Vertical closed-loop system. B. Open-loop groundwater system. C. Horizontal closed-loop system. D. Pond-loop system with auxiliary heating. Answer. Correct answer. C. Explanation. A horizontal closed-loop system is generally less expensive than vertical systems because it avoids deep drilling. Given adequate land and moderate climate, it's an optimal solution. Open-loop systems risk water contamination and require regulatory compliance. Vertical systems offer efficiency but are costly to install. Pond loops require nearby water body, which isn't mentioned. According to DOE guidelines and ICHPT standards, horizontal systems are ideal for sites with ample land and budget concerns. Question 4. The underlying principle of mechanical ventilation in green buildings is to provide fresh air while maintaining energy efficiency. Which of the following solutions best satisfies ASHRAE 62.1 for continuous IAC control with minimum energy penalty? A. Opening operable windows in each room. B. Using a heat recovery ventilate HOV. C. Installing a dedicated exhaust fan in each bathroom. D. Increasing the building's natural infiltration. Answer. Correct answer. B. Explanation. ARVS. Heat recovery ventilators meet ASHRAE 62.1 IAC standards while conserving energy by capturing heat from exhaust air. Option A. Lacks control and varies by climate. Exhaust fans C. Help in moisture control but not whole building ventilation. Infiltration D. Is passive and unpredictable. HRVS are considered best practice for green buildings and help achieve LEED credits under EC and E categories, especially when paired with demand-controlled ventilation and MER 13 filtration systems. Question 5. From a practical standpoint, Mr. Patel suspects that an older commercial rooftop HVAC unit is operating inefficiently. He notices inconsistent supply air temperatures and elevated energy bills. Which tool and approach combination would provide the most actionable data to confirm poor performance? A. Air thermometer and visual inspection of ductwork. B. Psychrometer and static pressure test. C. Combustion analyzer and refrigerant pressure reading. D. Digital multimeter and airflow anemometer. Answer. Correct answer. B. Explanation. Using a psychrometer provides temperature and humidity data indicating coil effectiveness. A static pressure test reveals airflow restrictions. Common causes of inefficiency, while air thermometers are useful, they lack depth. Combustion analyzers, C, are more suited for fuel-burning appliances, not general HVAC diagnostics. Multimeters, D, help with electrical issues, but not airflow. Following Standard 5 HVAC quality installation specification, airflow and psychrometric data are essential for diagnosing performance deviations. Question 6. Examining the consequences of thermal bridging, which component is most likely to undermine HVAC efficiency in a green building envelope if improperly designed? A. Interior gypsum wallboard. B. Exterior cladding materials. C. Steel framing members. D. Ceiling paint finishes. Answer. Correct answer. C. Explanation. Steel framing members conduct heat 300,400 times faster than wood, creating thermal bridges that bypass insulation and degrade R values. This increases heat and cooling loads, reducing HVAC efficiency. Interior drywall A and paint D have negligible conductive impact. Cladding materials B can influence heat gain loss but are generally outside the insulation barrier. ASHRAE 90.1 and LEED V.1 emphasize minimizing thermal bridging through thermal breaks, insulated sheeting, or alternative framing methods. Question 7. Given the circumstances, Rodriguez is overseeing a retrofit of a 1990s office building with R22 equipment. The system is nearing the end of life, and R22 has become expensive and environmentally regulated. What is the most appropriate strategy for transitioning this system to a green standard while minimizing risk and maximizing longevity? A. Recharge the system with a hydrocarbon refrigerant like R290. B. Perform a drop-in replacement with R407 without equipment modification. C. Replace the entire system with R400 TINA components. D. Use reclaimed R22 until the equipment fails. Answer. Correct answer. C. Explanation. The best long-term solution is full system replacement using R400 TINA or HVO-based refrigerants, ensuring compatibility and efficiency. R407B requires oil changes and doesn't perform identically. Hydrocarbons A, like R290, are flammable and not approved for retrofits in most commercial applications. Relying on reclaimed R22D is unsustainable and contradicts Section 608 of the Clean Air Act. EPA-SNAP rules discourage extending obsolete refrigerants in commercial HVAC systems beyond their life cycle. Question 8. The primary reason for choosing a radiant cooling system in a LEED-certified commercial building is A. It eliminates the need for any dehumidification system. B. It provides cooling through direct contact with occupant skin. C. It reduces the energy used for moving air throughout the building. D. It increases the reliance on high-velocity duct systems. Answer. Correct answer. C. Explanation. Radiant systems cool surfaces rather than air, reducing reliance on fans and air movement. This decreases electrical energy consumption for air transport, contributing to LEED credit compliance. While radiant cooling affects occupant comfort, B. It's via surface temperature, not direct contact. Dehumidification A is still essential to avoid condensation. High-velocity ducts D are unrelated, even discouraged with radiant systems. ASHRAE 55 supports radiant systems for thermal comfort in green design. Question 9. While examining proper PPE for refrigerant recovery, which standard best dictates the required eye and skin protection for handling low-temperature refrigerants in HVAC systems? A. ASHRAE Standard 15. B. NFPA 7-TI. C. OSHA 1910 Subpart I. D. ANSI ASHRAE 62.2. Answer. Correct answer. C. Explanation. OSHA 1910 subpart I outlines personal protective equipment requirements, including gloves, goggles, and face protection during refrigerant handling, and ASHRAE 62.2D concerns ventilation. ASHRAE 15A governs refrigerant safety but doesn't specify MEP. NFPA 7-B is electrical safety focused. Refrigerants like R400 TINA can cause frostbite or chemical burns. Therefore, OSHA compliance ensures technicians are protected from physical and chemical hazards. Question 10. To illustrate this point, Mr. Evans is conducting an energy audit on a multifamily building. He identifies high usage during peak hours and notes oversized HVAC units cycling frequently. What is the most cost-effective, sustainable recommendation to improve system performance and reduce energy demand? A. Install a larger system with increased cooling capacity. B. Add thermal storage tanks to delay cooling load. C. Replace units with correctly sized high-efficiency systems. D. Install solar PV to offset electric costs only. Answer. Correct answer. C. Explanation. Oversized systems short cycle, leading to inefficiency and poor humidity control. Replacing them with properly sized, high-efficiency equipment optimizes runtime and load matching. Core elements in HVAC, manual JSD and LED credits. Larger units A. Worsen the issue. Thermal storage B. Helps in specific applications but adds cost complexity. Solar PV D. Reduces utility cost but resolve the system inefficiency. ASHRAE 90.1 emphasizes right-sizing HVAC for true energy savings. Question 11. According to recent studies, which approach best explains how a high C-rated air conditioning system contributes to green building goals when compared to a standard rated system? A. It extends the equipment warranty by an additional 5 years. B. It allows the use of outdated refrigerants without penalty. C. It consumes less energy for the same cooling output, reducing emissions. D. It reduces the building's ventilation requirements significantly. Answer. Correct answer. C. Explanation. High SEER seasonal energy efficiency ratio systems provide more cooling per unit of energy used, directly reducing operational carbon footprint and utility costs. This supports both Energy Star certification and compliance with ASHRAE 90.1. Warranty length. A. Is manufacturer specific. Outdated refrigerants. B. Are often banned or regulated under the Clean Air Act. Ventilation. D. Governed by ASHRAE 62.1 and is unrelated to SEER. High SEER units help green buildings earn LEED E credits. Question 12. The most significant aspect of selecting a refrigerant for a green HVAC system is A. Ensuring it is colorless and odorless for occupant safety. B. Choosing one with the lowest possible OWD. Selecting a refrigerant that operates at the highest pressure. D. Using one with the longest manufacturing track record. Answer. Correct answer. B. Explanation. Green HVAC practices emphasize using refrigerants with low ozone depletion potential and low global warming potential. These align with the Montreal Protocol and EPA SNAP program. Color A and age of use. D. A secondary. Higher pressure. C. May increase energy use and safety risk. Examples like R1234F and R744 Co. illustrate sustainable goals. ANSI ASHRAE Standard 34 and EPA Section 608 guide refrigerant selection and classification. Question 13. With the advent of new construction in mixed climates, Istalin is installing a split system heat pump in a residential green building. The refrigerant lines must run approximately 50 feet with multiple bends. To comply with best practices and avoid energy penalties, what must Istalin prioritize during installation? A. Using copper pipes with extra insulation on return lines only. B. Keeping the refrigerant line as short and straight as possible. C. Burying all refrigerant lines underground for protection. D. Avoiding nitrogen purging to save time. Answer. Correct answer. B. Explanation. Minimizing line length and bends ensures correct refrigerant charge and reduces pressure drop, crucial for energy-efficient operation and longevity. Line design is part of Manual S and manufacturer installation guidelines. Excessive length causes poor oil return and capacity loss. Nitrogen purging D is essential to prevent contamination. Underground piping C introduces condensation and heat gain. Return-only insulation A is insufficient. Both lines should be properly insulated per ASHRAE and OEM standards. Question 14. When evaluating the merits of combined heat and power (CHP) systems in green buildings, what is the most compelling advantage over conventional HVAC systems? A. CHP systems require no utility grid connection at all. B. CHP systems recover waste heat for additional thermal loads. C. They only operate during emergency power outages. D. They operate silently and require no combustion. Answer. Correct answer. B. Explanation. CHP systems, also called cogeneration, generate electricity and capture waste heat for use in heating or domestic hot water, increasing total system efficiency to over 80%. This aligns with LEED E-credits and DOE Advanced Energy Retrofit Guides. They're not off-grid. A. Not limited to emergencies. C. And most use combustion. D. ASHRAE 100 and green building codes encourage CHP use in large-scale and district energy projects. Question 15. The conventional wisdom about refrigerant leak management in green buildings stresses early detection. Which of the following technologies provides the most precise detection of small leaks for systems using DOE refrigerants? A. Soap bubble testing on all fittings. B. Halide torch testing during system operation. C. Infrared leak detectors with calibrated sensitivity. D. Relying solely on pressure drop over time. Answer. Correct answer. C. Explanation. Infrared leak detectors offer precise, repeatable detection for modern refrigerants like HFOS and hydrocarbons. They're more sensitive than soap bubbles, and safer than halide torches. B. Pressure drop monitoring. D. Is slow and may miss microleaks. EPA Section 608 and ASHRAE Guideline 147 emphasize proactive leak detection as critical to sustainability and regulatory compliance. Advanced sensors help avoid environmental harm and ensure refrigerant containment. Question 16. Taking into account current green building practices, why is manual J-based load calculation essential before HVACR equipment selection in residential applications? A. It guarantees oversized equipment for better cooling. B. It allows installers to avoid ductwork design. C. It ensures systems are properly sized for comfort and efficiency. D. It automatically qualifies the project for LEED certification. Answer. Correct answer. C. Explanation. Manual J from a CAP ensures accurate HVAC sizing by factoring in insulation orientation, windows, and occupancy. Correct sizing avoids energy waste and short cycling. Oversizing A. Reduces dehumidification. Duct design B. Requires manual D. LEED certification D. Needs broader documentation beyond manual J. Manual J-based load calculations are critical under Energy Star and ASHRAE guidelines to achieve energy efficiency and occupant comfort in green homes. Question 17. By evaluating building performance software like EnergyPlus or Request, which of the following is the most strategic use of these tools in green HVAC system design? A. To generate schematic drawings for mechanical contractors. B. To estimate first cost of equipment for budget planning. C. To simulate annual energy consumption and optimize design. D. To perform real-time monitoring after installation. Answer. Correct answer. C. Explanation. Energy modeling tools like EnergyPlus simulate annual HVAC loads and energy use, helping designers optimize equipment selection and layout for maximum efficiency. This supports LEED documentation, E-credit, optimize energy performance. These tools don't create schematics. A. Real-time monitoring. D. Is for BAS systems and cost estimation. B. Is outside their primary function. ASHRAE 90.1 Appendix G requires energy modeling for performance-based compliance paths. Question 18. Historically speaking, what is the key environmental benefit of natural refrigerants such as coal R744 and ammonia R717 in green HVAC systems? A. They reduce system efficiency but improve noise control. B. They have negligible or zero global warming potential. C. They prevent the need for leak detection systems. D. They are universally non-toxic and safe. Answer. Correct answer. B. Explanation. Natural refrigerants like coal and ammonia have nanoid, making them ideal from an environmental standpoint. They're favored in green applications and aligned with Kigali Amendment goals. Ammonia is toxic and requires safety measures. D. Leak detection is still required. C. Especially with toxicity, while efficient, their use doesn't always improve noise levels. A. ISO 817, ASHRAE 34, and EU gas regulations promote these alternatives for sustainability. Question 19. The growing trend in state-level energy efficiency programs has prompted Mr. Norris to consider replacing his aging gas furnace with a variable-speed heat pump. What steps should Mr. Norris take first to maximize available rebates and financial incentives for this green upgrade? A. Begin installation and file rebate paperwork afterward. B. Select a system solely based on lowest upfront cost. C. Review utility rebate eligibility and pre-approval requirements. D. Wait until the tax season to apply for federal credits only. Answer. Correct answer. C. Explanation. Many utility and state incentive programs require pre-approval or use of certified contractors and equipment, e.g. Energy Star. Skipping pre-approval A. May void incentives. Lowest upfront cost. B. Often overlooks long-term savings and eligibility. Federal credits. D. Are useful but may not include local utility offers. Programs like DSIRE, Energy Star Rebate Finder, and local PUT resources provide guidance. LEED and RISNET standards encourage integration of available incentives during early design. Question 20. A critical examination of psychrometric principles reveals that latent heat plays a crucial role in green HVAC design. How does understanding latent heat behavior improve system performance in humid climates? A. Ensures systems are oversized to remove more humidity. B. It allows designers to ignore air movement in the space. C. It helps optimize equipment to maintain comfort and prevent mold. D. It eliminates the need for ventilation in humid areas. Answer. Correct answer. C. Explanation. Latent heat refers to moisture removal from the air, crucial in humid climates to prevent condensation, mold, and comfort issues. Psychrometric analysis helps ensure dehumidification is properly addressed, particularly in energy-efficient buildings where oversized systems may short-cycle A. Air movement, B, and ventilation, D, remain necessary. ASHRAE 55 and 62.1 emphasize thermal comfort and IAC, both of which depend on latent load management. Green buildings must balance humidity and efficiency for sustainability. Question 21. In a modern context of green HVAC maintenance, Barnes notices that the evaporator coils of a high-efficiency air handler have accumulated dirt and biological growth. What is the most impactful maintenance action she should prioritize to restore system efficiency and IAC without replacing equipment? A. Increase the system's airflow to compensate. B. Schedule thyrocoil cleaning with EPA-approved cleaners. C. Replace all air filters immediately. D. Lower the thermostat set point to reduce load. Answer. Correct answer. B. Explanation. Dirty coils reduce heat transfer efficiency, forcing compressors to work harder and increasing energy use. Coil cleaning removes contaminants that block airflow and degrade IAC by harboring mold or bacteria. ASHRAE Standard 62.1 and EPA guidelines recommend regular coil cleaning to maintain performance and occupant health. Increasing airflow A won't address the root cause. Filters C help but are less effective if coils are fouled. Lowering thermostat D increases load and energy consumption. Question 22. From multiple perspectives, what is the primary consequence of poorly sealed and insulated ductwork in a commercial green building's HVAC system? A. Increased noise levels but no energy penalty. B. Improved ventilation effectiveness. C. Significant loss of conditioned air causing energy waste. D. Reduced need for air filtration systems. Answer. Correct answer. C. Explanation. Leaky ducts allow conditioned air to escape into unconditioned spaces, wasting energy and increasing HVAC operating costs. This also compromises occupant comfort and indoor air quality by potentially introducing contaminants. ASHRAE 90.1 and I require duct sealing and insulation to reduce energy loss. Noise issues may occur but are secondary. Ventilation B is not improved by leaks and filtration needs D remain unaffected or worsen. Question 23. Given the circumstances, Istanuen is performing refrigerant recovery on an HVAC system in a building undergoing renovation. The refrigerant is classified as a DEF according to EPA Section 608. What is Istanuen's legal obligation during this recovery? A. Release the refrigerant outdoors after partial recovery. B. Use approved recovery equipment and properly recycle or reclaim refrigerant. C. Vent the refrigerant into safe containment device inside the building. D. Dispose of the refrigerant as regular waste in landfill. Answer. Correct answer. B. Explanation. EPA Section 608 prohibits venting refrigerants and mandates use of certified recovery equipment to capture refrigerants for recycling or reclamation. Proper handling prevents ozone depletion and greenhouse gas emissions. Options A, C, and D violate federal law and can result in fines. The Clean Air Act requires strict documentation and disposal per EPA guidelines. Technicians must hold EPA 608 certification for legal compliance. Question 24. The fundamental question is, when conducting a commercial energy audit, which measure most effectively identifies opportunities for energy savings without costly equipment replacement? A. Measuring and reducing air leakage in building envelope and ducts. B. Replacing all lighting fixtures with LED options. C. Installing new chillers with higher capacities. D. Installing photovoltaic panels on the roof. Answer. Correct answer. A. Explanation. Air leakage leads to significant heating cooling losses, and sealing leaks is typically cost-effective with a fast ROI, while lighting upgrades. B. And PV installation. D. Also save energy. They require capital and may not address HVAC inefficiencies. New chillers. C. Are expensive and only advisable if existing equipment is inefficient or failing. ASHRAE Guideline 14 emphasizes envelope tightness in audit procedures for accurate savings estimation. Question 25. With respect to VRF systems in mixed-use green buildings, what key advantage differentiate VRF from traditional HVAC systems in terms of energy efficiency? A. VRF systems have fixed capacity compressors. B. ERF systems modulate refrigerant flow to match precise zone loads. C. ERF systems eliminate the need for any air filtration. D. ERF systems operate solely on renewable energy sources. Answer. Correct answer. B. Explanation. ERF technology modulates refrigerant flow based on real-time load demands for each zone, reducing energy waste from overcooling or overheating. This dynamic capacity control is a significant advantage recognized in ASHRAE and LEED guidelines. Fixed capacity compressors, typical of older systems. ERF systems still require air filtration. C. And generally operate on grid power. D. Exclusively renewables. Properly designed ERF systems contribute to green building certification through load matching and energy savings. Question 26. During the process of commissioning a new HVAC system, Chen observes that supply airflow rates exceed design specifications. What is the most likely impact on system efficiency and occupant comfort if left uncorrected? A. Improved indoor air quality with no energy consequences. B. Increased energy consumption and potential noise and draft issues. C. Enhanced humidity control. D. Reduced need for regular filter changes. Answer. Correct answer. B. Explanation. Excessive airflow increases fan power consumption, raising operating costs. It can also cause drafts and noise, negatively impacting occupant comfort. ASHRAE Guideline 0 and 1.1 highlight balancing airflow for energy-efficient and comfortable operation. Over-ventilation does not necessarily improve IAC and may disrupt humidity control. C. Filter replacement frequency. D. Is not directly reduced by high airflow. In fact, filters may clog faster. Question 27. Considering the evidence Istadias is designing a solar thermal system integrated with HVAC for a medium-sized commercial building, which of the following best justifies integrating solar thermal for HVAC rather than photovoltaic panels alone? A. Solar thermal systems provide direct heat for water or space heating with higher efficiency. B. Photovoltaic panels are more cost-effective and easier to install. C. Solar thermal systems do not require pumps or controls. D. Photovoltaic panels cannot contribute to HVAC energy savings. Answer. Correct answer. A. Explanation. Solar thermal collects heat directly, providing efficient hot water or space heating and reducing HVAC heating loads. PV panels generate electricity, which can run HVAC equipment but with conversion losses. Although PV is versatile and often simpler, solar thermal's direct heat capture is more efficient for thermal loads. Solar thermal requires pumps and controls. PV panels do contribute to HVAC energy savings, but indirectly lead in Green Globe's credit systems that reduce fossil fuel use via solar thermal. Question 20. In response to the growing adoption of dope refrigerants, what important procedural change must technicians like HRConquer implement when recovering these refrigerants compared to legacy HFCS? A. Use the same recovery equipment without changes. B. Recover refrigerants at low pressures and avoid contamination. C. Vent refrigerants after recovery is complete. D. Convert refrigerants into less harmful compounds on site. Answer. Correct answer. B. Explanation. Refrigerants such as HFOS and hydrocarbons often operate at low pressures and are sometimes flammable or mildly flammable. Recovery equipment must be compatible and operated carefully to avoid contamination and maintain safety per EPA Section 600A. Venting C is prohibited. On-site chemical conversion D is not a legal or practical practice. Proper recovery protects the environment and ensures regulatory compliance with updated refrigerant handling protocols. Question 29. When evaluating the payback period for a current HVAC retrofit project, which factor most significantly influences a shorter payback period for energy-efficient equipment installations, A. Availability of utility rebates and incentives, B. Higher initial capital investment, C. Longer equipment warranties, D. Installation in buildings with poor insulation. Answer. Correct answer. A. Explanation. Utility rebates and incentives reduce upfront costs, improving project economics and shortening payback. High initial cost B usually lengthens payback. Equipment warranties C don't affect payback directly. Poor insulation D increases energy demand, reducing efficiency benefits and extending payback. Programs like DSIRE and Energy Star rebate offerings are key considerations in green financial planning, aligned with LEED and ASHRAE 90.1 guidelines. Question 30. Within the framework of green HVAC design, what is the principal advantage of incorporating a dedicated outdoor air system (DOAS) in a commercial building ventilation strategy? A. It eliminates the need for any air filtration downstream. B. It supplies 100% outdoor air with independent temperature and humidity control. C. It reduces the size of the heating and cooling equipment to zero. D. It increases overall system complexity without energy benefits. Answer. Correct answer. B. Explanation. DOAS separates ventilation from space conditioning, supplying 100% outdoor air with precise temperature and humidity control. This improves indoor air quality per ASHRAE 62.1 and enhances energy efficiency by allowing main HVAC systems to focus on sensible loads. DOAS still requires filtration. A. It does not eliminate heating cooling equipment. C. While it adds some complexity. E. Energy and IAC benefits are well documented and valued in LEED and Green Globe certifications.